All right, kiddos, welcome back to our example video for electron configurations. We're going to start off by doing something a little bit more complicated than the one we did before, and that's going to be Cobalt. Remember, you've got your three rules from last time. You've got your Aufbau principle, your Pauli exclusion principle, and Hund's rule. Start at the bottom, no more than 2 per orbital or 2 per box. And then if the boxes are in the same line or the same energy level, then we're going to put 1 electron in each before we go back and put 2 in any. Everybody gets a piece before anybody gets seconds. Okay, so those are your 3 rules. Also remember, and I'll write this off to the side here real quick, I'm going to put over here to the side. Also, don't forget that S's get 1 orbital, that P's get 3, that D's get 5, and F's get 7. Okay, and that is going to be important as we draw our orbitals here and fill them in with electrons. So we're going to start at the bottom then. And up here, remember the first level is 1s, so I'm going to start there. I've got 1 box because S's have 1. 2s, again 1 box. So that was 1s, 2s, 2p. Remember that p's have 3 orbitals. Okay, so I finished off row 2. I come back to row 3, and I've got 3s with 1 box. So 3s to 3p. And again, you should be drawing along with this, like with your finger on your periodic table to make sure that you're understanding where the rows work. If you're not, stop now, get your periodic table and do that. Okay, so we ended here at 3p. We come back over here to 4s. Again, 1 box. And now we're finally into the D territory. And so the natural thing would be to think that this is 4D coming up next. But if you remember from the last video that our Ds are always 1 energy level below where our S and our Ps are. So even though this row right through here would be 4S and 4P, that this is 3D. They're always 1 below. And so that's actually, by the way, what makes this sometimes complicated for students. If they went in a nice numerical order, then it would be a piece of cake. You wouldn't have to memorize what order things go in. And by the way, you don't really have to memorize what order goes in. Your periodic table is your friend. Okay, follow the periodic table along, and then just keep in your mind that the D's are always 1 below whatever level you're in. Okay, so I've got my orbitals drawn out. Remember, D has 5, so 1, 2, 3, 4, 5 boxes there. And then what is important next, the next step that you do after you get your boxes drawn, and by the way, you'll be able to have some of the boxes. Usually when you start out, you're going to want to look at them as you do them. And it's only as you get some familiarity with them and do 3 or 4 of them that do you need to stop and think, hey, am I memorizing this? Am I knowing what the order of these things are? So I've got 27 electrons, okay? And so I always like to write that down. I'm doing cobalt. I've got 20, and that's not good because that almost looks like carbon monoxide. Cobalt, 27 electrons. And so we're going to fill in 27 electrons. Remember your 3 rules. We start at the bottom, no more than 2 per box. Anytime we get to degenerate orbitals or orbitals that are all the same, we're going to put 1 in each before we go back and put 2 in each. Okay? So 1, 2, 3, 4, 5, 6, 7. Following Hund's rule. Honestly, it wouldn't really matter until you get to the end, but I'm going to keep doing it just for practice anyway to make sure I've got it right. So that's 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay? Always good sometimes too as you go along to make sure that you're sort of keeping count. I usually do it off to the side and sort of note myself, hey, I've got 10, I've got 20. That way I don't lose count, because as you get to the ones like the next one we're going to do where you're counting to like 100, then you want to make sure that you're not losing count somewhere along. So I've got 20. I've got 7 left to put in. We're going to do Hund's rule up here. So Hund's rule fills us in so that we have 25, 26, 27 electrons, and that is my proper orbital notation for cobalt. And again, just to recap real quick, we start at the bottom, Aufbau principle. Only 2 in each box, and they have to be arrows going opposite ways. The up arrow always comes first, down arrow always comes second. That's the Pauli exclusion principle. When we get up to degenerate orbitals that are in the same have the same energy, then we put 1 in each before we go back and put 2 in any. That has some profound chemistry implications. That's the reason why we do that, because those electrons that are alone are going to tend to be able to form bonds and do things like that, maybe a little bit easier than the ones that are paired up. And so that's going to matter to us. Okay, so that's cobalt. Let's do one that's a little bit more complicated in this orbital notation or longhand notation. And then in the next video, we'll talk about shorthand and noble gas core. Okay, so for this one, we're going to do tantalum. Tantalum is way on down there. We've got 73 electrons that we're going to have to count out. And you're like, holy cow, do I have to count out and draw out all those electrons? And the answer to that is yes, at least for now. You need some practice in being able to do those. And I'm a big believer in you should have to practice some of the harder ones to make sure, just in case those show up. The real answer is, if you're worried about like your end of course exams or something like that, it's pretty rare that they're going to give you something that high. But certainly as you get into your college chem and stuff, all of those things are fair game. And so I think you should be able to see one work. So 73 is way on down. We're in the D block here. Okay, so we're in that valley of the periodic table. So I know I'm going to end in D. And specifically, if you look on your periodic table, and remember, if you look down the side of the periodic table, there are numbers down the side. So there's 1, 2, 3, 4, 5, 6, 7. Remember that those are your periods, and those correspond to the energy level. They also correspond to what orbitals for S and P you're in, right? So 1s, 2s, 3s, so on and so forth. Remember that our Ds, okay, so D block starts here, right? Our Ds are always 1 below. So even though this is in the line with 6, energy level 6 or period 6, I know that that's going to be 5D is where I'm going to end. And so that's going to give me some useful information. I'm going to go ahead and start with where I end in this case. Now, I'm not going to fill my electrons yet, so I'm not violating the Aufbau principle, but that will like give me a final point so I know where I'm going to end at. You, by the way, can do that every time you do an electron configuration. If you're doing fluorine up here, you're like, hey, I'm in the P block, I'm in row 2, I'm going to end in 2P, and you can sort of immediately know. And really, once you get good at this, and we'll see this with shorthand electron configuration, you can count the number of boxes over and know like exactly how many orbitals you're going to end in. So in the case of my fluorine, I would be 1, 2, 3, 4, 5 boxes over. That would mean that I would have 5 electrons in the 2p. Okay, anyway, I digress a little bit. So 5D is where we're going to end. We're going to start at 1s and work our way up from there. I just wanted to make sure that I had left some space. But in this case, I'm actually going to work backwards a little bit, because I think if I started with 5D here, if I work backwards to draw my boxes and then I can go back in and fill the electrons in up after that, I might get maybe a little bit better sense of how these things work. So also one thing to remember is that right here at the line between S and D in the 6 and 7 slot is where the F block is. And if you remember, we said that this was 4F and this was 5F. Okay? And so if we slid these back up here, 4F would be right before tantalum. Okay? And so I'm going to make that my next set of boxes here. That's the 4F. Remember that there are 7 orbitals or boxes in my 4F. 4, 5, 6, 7. Make sure that I've got enough space between those guys there. Okay? And then we're going to keep going backwards, just because I think it's important for you to be able to see the order these things go in. So that was 4F was right here. Okay? This was my 5D, 4F. 6S is next. Okay? Then we come back over to this side. We're in row 5 now, 5P. Hopefully you're sort of starting to get the hang of it a little bit. So that was 5P. We're now in the D block. And remember, the D is always 1 below whatever S and P it's wedged between. 5 boxes. D's have 5. 5S. Okay? And so on and so forth. So I'm going to go ahead and draw the rest of this out. You should be tracing this along with your finger on the periodic table to be able to identify where each of these spots are. S, P, D, F, row 1, 2, 3, 4, 5, 6, 7. Make sure that you can do that. And I'm going to pause here, and we're going to complete the table, and then we'll go ahead and draw everything in. Okay, so 1S all the way up to 5D. We've got 73 electrons. Let's fill in those electrons. Let's follow our rules. Start at the bottom, 2 in each box. When I get to these, I've got to put 1 in each box before I go back. Again, that doesn't really matter until the last one, but I'm going to be consistent with what I told you was the rules. So I'm going to fill these up for you. Alpha, start at the bottom. Pauli exclusion, 2 in each box. Up, down. Ups always come first. We did Hund's rule. I put 1 in each box, and so on and so forth. So let me fill in the rest of these, and then we'll talk about it. Now, I know that I'm going to end up here at 5D, but I think it's really important, as I said in the last time, to sort of make sure that you know what number you're at as you're going up. And so I just sort of count along as I'm going. But so at this point, I've got 30 right here at the end of 3D. And so that's 38. That's 48. I just want to make sure that I'm on the right track. So I'm at 49, 50, 1, 2, 3, 4. Okay, 55, 56. Now it's where it starts to get like we're going to fill in a bunch. Again, Hund's rule, really important here. So 1 in each of those boxes. Then we can go back and fill in the others. How do I know that the others fill in? Well, I'm going to end in 5D, so everything below it is going to have to be filled, with the fact that there are a couple of exceptions that we'll talk about in class. So that leads us to 70. And so now I've got 73. I've got 3 more. 1, 2, 3. Now, if you go over and you look at your periodic table, please do that right now. Pause, grab your periodic table. We're in the 6th row, which means our D block is 5, and we're going to be 1, 2, 3 boxes over. That gives us our tantalum, our correct electron configuration. I just mentioned that there were a few exceptions, and we'll talk about those specifically, but you might want to look those up. Things like copper and chromium are going to be exceptions, because when you start to get your Ds and your Ss here, the Ds and the Ss, like this 4S and this 3D, they're really close together. They're almost degenerate together if we really drew them out the way they should be. And so that means that sometimes the Hund's rule means that there's some weird sharing in between those that isn't what we would think is the standard method. But as far as the standard method for orbital notation, this is it. We're going to jump in here in a second into our next video, and we're going to talk about shorthand and noble gas core electron configuration after that. Okay? Thanks, kiddos.